Hello coders, in this video we will solve question which we solved yesterday in using BFS. In this video we will solve it using BFS. Let me take you to the screen first. And yeah, here this is the question, which is the reorder route to make all paths lead to the city 0. Basically this question says that we have n nodes, we can say that n cities 0 to n which are numbered from 0 to n minus 1. We have connections which basically have a vector of edges. H AI to BI, H will contain AI BI, and it is AI to BI. Like direction is from AI to BI. It is basically a directed graph. It and yeah, and what this says ki there is a event in city 0, and for that we need to uh, change the direction of edges such that from every node we can reach to the city 0. So for that, what we can do here, ki we have nodes, we have connections. First we will convert that to the adjacency list. That the representation of graph will be in the form of adjacency list. And while making that, to know the direction of edges, we will say ki if it is directed from A to B, then while pushing B to the adjacency list of A, I'll push it as it is. But while pushing A to the B, I'll push it as a negative. It means ki we made it we made that graph as a bidirectional, or we can say ki undirected graph, but we remember the direction by the signs. If it is a positive, then it is uh, sign it is correct sign, and if it is a minus, then it is a reverse sign. So using plus and minus, we understood that, and now we can solve it using BFS. Let's see how we can solve it. uh, well, BFS means just going level wise, solving it level wise, right? So we will first, what we will do ki, uh, we will take 0, and from 0, from wherever I can go, I want to reverse that, right? Because I want to come 0, not to go away from 0. So I'll take 0, and whichever nodes are whichever nodes are there in zeros addition list, uh, I'll check it ki if I'm going from 0 to that node, that it is a directed edge, that is the node is in positive sign, then I will add 1. And if it is negative, it means ki I'm already coming from that node to the 0, so I will not add 1. So basically, if that node sign is positive, then I will add 1, and if it is negative, then I won't add 1. And I will do like this for the next nodes. First I'll start from 0, from 0 where I can go, I'll see. From those nodes where I can go, I'll see, and I'll reverse those edges. Okay, yeah, I think you understood, and let's code it. So first we will let's take a last code from a last video, and you can check my video. It's just last video, and yeah, I'll take this code as it is, and I'll just write BFS function rather than writing the BFS one, because yesterday we wrote BFS and we saw how it works, and today we will see how BFS works. So first we will convert the connections to, we will make a graph in the form of adjacency list like this, and as I said, we will push negative view to the V. We take a visited, then we will say ki it is a BFS, and start the BFS from 0. Take adjacency list and visited. I'll write a BFS function. I have node, I have adjacency list. For BFS, I'll need queue of int. I will say ki it is a queue. I'll push the queue. I'll push node to the queue, and a rule which is whenever I push node to the queue, I have to mark it as visited. I mark that as visited. Then while my queue isn't empty, queue dot empty. While my queue isn't empty, what I will do? Ki I will take node is equals to q dot front and q dot pop. I use this node which was here declared, so I didn't say int node. I just took node as it is. Node q dot front q dot pop, and I'll use this for loop as it is. But I'll say कि for neighbor node from that adjacency node list, if it isn't visited, absolute value of neighbor, cause it can be negative also. If it isn't visited, then push it to the queue, and as soon as I push it, I mark it as visited neighbor and one. And what I have to do ki to check if it is positive, then I have to add 1 cause I have to reverse that edge, and then I will return the changed edges. Okay, so yeah, we'll do this, we'll run it and we'll submit it. It is accepted. So time complexity for this will be time complexity will be here we took edges and we pushed it, then we go to the we created a visited vector, then we went to the BFS, and BFS also we took Q, and while Q isn't empty, though there are two loops, that is while and for, we are checking visited or not. So if we are visiting every node just once, so we will say the time complexity will be big of n, and space complexity for this will be big of n, as we are using Q and we are storing the nodes, and also we have took a visited vector of size n, so space complexity for this will be big of n. So yeah, that's it for today's, we'll meet in next video. Till then, bye bye.